In today's lesson, we're going to talk about properties of lines. If you recall, the slope-intercept form of a line is y equals mx plus b. You should have this memorized by now. The variable of m represents slope, while the variable of b represents the y-intercept. In previous lessons, we learned that the slope is also known as the rate of change, and we also learned that the y-intercept is the same thing as the initial value. So I'm just going to circle that so that you know they're all the same. We also learned that y represents the dependent variable and x represents the independent variable. In our first example, we're going to look at lines with positive slopes. If you recall, lines with positive slopes point upwards. These lines also show a positive correlation between the two variables because as one variable increases, the other increases as well. The equations of these two lines are already written over on the left side. However, I'm going to go ahead and figure out the equations of these lines by looking at the graph. So let's zoom in, and I'm going to first analyze the blue line. As you can see, the y-intercept is 4. Instead of saying y-intercept, I'm going to use its variable, and the variable is b. So let's point to that. Next, I want to find the slope of this line. I'm going to choose any 2 points. Let's choose these 2 points. I'm going to create a little triangle. You can create one on the top of the line or at the bottom of the line. It doesn't matter. So I'm going to create one here underneath the line. As you can see, the run is equal to 3, while the rise is equal to 1. The equation for slope is rise over run. You should have this memorized by now. Instead of using slope, I'm going to use the variable of m. The rise happens to be 1, and the run is 3. That fraction cannot be reduced, so you can leave it as is. Now that we've figured out the slope of the blue line and the y-intercept of the blue line, we can go ahead and write its equation. And let's just do that over on the side. You want to start with the general equation of a line, which is y equals mx plus b. We've already figured out what m is, and we've already figured out what b is. So we're going to put those numbers in. M is equal to 1 over 3x plus the y-intercept, which is 4. Now we're going to figure out the equation of the red line. So let's zoom in. Again, the easiest thing to do is to figure out the y-intercept. So the y-intercept here is equal to 2, and I'm going to use the variable of b. b is equal to 2, and I'm just going to write a little arrow to show you where that is. Next, we want to figure out the slope of the red line. So what you can do is choose any 2 points on the red line, preferably on the grid lines. So let's go ahead and do that. Again, you can write your triangle above or below. I'm going to write it above, like so. Over here, your rise is 3, and your run is 1. Using those values, we can figure out the slope of the red line, because slope is equal to rise over run, and m is equal to 3 over 1. You should know that anything divided by 1 stays the same, so that is just 3. Now that we've figured out the y-intercept of the red line and the slope of the red line, we can go ahead and write its equation over on the side. So again, let's start with the general equation of a line, which is y equals mx plus b. We know what m is equal to, we just figured that out, and we know what b is equal to. We also just figured that out. So that's going to be y equals 3x plus 2. If you look over to the side, you'll notice that the equations of these two lines matches exactly. Why did we figure out the equations of these lines? Well, I wanted to compare the slopes. The slope of the blue line is 1 over 3, and the slope of the red line is 3. As you can see from the diagram, the red line is steeper. So I'm going to say red line is more steep. And I'm going to write the blue line is less steep. Now let's compare that to the slopes. The slope of the red line is larger. So slope is larger. And if you take a look at the slope of the blue line, which is 1 over 3, that is smaller. So slope is smaller. And that is our relationship. If a line is steeper, the slope is going to be larger. And if the line is less steep, then the slope is actually going to be smaller. In our second example, we're going to look at two lines which are pointing downwards. And if you remember, lines that point downwards have a negative slope. So I'm just going to write that on the top so you remember that. And if they have a negative slope, then a negative correlation exists between their variables. So I'm going to spell that negative correlation, which means as one variable increases, the other decreases. Over on the left, we already know the equations of these two lines. I'm just going to write it out so it's a little bit larger for you to see. The equation of the red line is y equals negative 3x plus 2, and the equation of the blue line is y equals negative 1 over 3x plus 4. Again, you'll notice that both these slopes are negative as these lines are pointing downwards. If you look closely at the two lines, you'll notice that the red line is much steeper than the blue line. So let's make a little note of that. More steep. And the blue line would be considered less steep. If you recall from a previous example, if a line is more steep, it has a larger slope value. So I'm going to write larger slope. And if a line is less steep, it will have a smaller slope. The numbers back that up. 3 is larger than 1 over 3. In our third example, we're going to look at two lines which are parallel. So we're going to call this parallel lines. In other words, these two lines never intersect one another. They never cross each other. They just keep going on and on forever without touching, kind of like railroad tracks. Again, over on the side, we are already given the equation of these two lines. I'm going to write them out so it's a little bit bigger. The blue line has an equation of y equals 1 over 2x minus 2, while the green line has an equation of y equals 1 over 2x plus 3. You should notice something similar between these two equations. Their slopes are exactly the same. So the slope of the green line is 1 over 2, and the slope of the blue line is also 1 over 2. Let's make a conclusion about our findings. Therefore, we can say parallel lines have the same slope. We can also make a statement which is essentially the reverse of our first statement. If lines have the same slope, they must be parallel. In this example, we're going to look at the special case of a horizontal line. A lot of students forget the difference between horizontal and vertical. I want you to think of the word horizon. When you look at the horizon, it is straight going from left to right. So maybe you might be looking at a sunset in the horizon, okay? Over on the left, you'll see that the equation of this line is y equals 2, which looks nothing like our previous examples because we know the general equation of a line is y equals mx plus b. That's why horizontal lines are a special case. The method of determining the equation of a horizontal line is actually quite easy, and this is what you do. I want you to pick any 2 points on this horizontal line. I'm randomly going to choose this point, and I'm randomly going to choose another point. I want to write down the coordinates of this point. This point is 1, 2, and the coordinate of this other point is 4, 2. If you recall, a coordinate is made up of an x and a y, an x and a y. When you look at these 2 coordinates, you need to ask yourself, what number is the same? The number that is the same is 2, and 2 happens to be the y coordinate. Therefore, y equals 2 is going to be the equation of the line. Because as you can see here, the y coordinate always stays the same. You use the same method to figure out the slope. So let's look at these 2 points. You can't really make a triangle between these 2 points, but we can draw an arrow. And that is going to represent the run. The run happens to be 3, okay? And because we can't draw the triangle, you will say that the rise is 0. Using those 2 numbers, we can plug those into our slope equation. So slope is equal to rise over run. The rise is 0, and the run is 3. 0 divided by 3 is 0. I'm just going to fill those in. Therefore, the slope of a horizontal line is always 0. Doesn't matter where it is, the slope is always 0. However, the actual equation of the horizontal line can change. In our last example, we're going to look at a vertical line. Like I said earlier, some students get confused between horizontal and vertical. You can think of this as the vertical of someone's jump. So often athletes describe how high they jump with something called their vertical. Okay? We're going to use the exact same method as our previous example to find the equation of this line. And remember, it's a special case. So let's go ahead and choose any 2 points on this line. I'm going to randomly choose this point, and I'm randomly going to choose that point. The coordinate of the first point is 2, 2, and the coordinate of the second point is 2, 5. Again, remember, a coordinate is made up of an x and a y, an x and a y. You need to ask yourself at this point, what number is the same? So the 2 is the same, and the 2 happens to be the x coordinate. Therefore, the equation of this vertical line is x equals 2. Because no matter where you are on the line, x is always going to be equal to 2. Let's go ahead and figure out the slope of this line. We can't really create a triangle here, but we still can figure out what the rise is. The rise is equal to 3, and the run, there is no run, so you can say run is equal to 0. Let's zoom back out and let's figure out what that is equal to. So you should have your slope equation memorized by now. slope is equal to rise over run. You plug your numbers in, your rise is 3, and your run is 0. I want you right now to go ahead and plug this into your calculator. If you plug this into your calculator, you won't get an answer. It will say error. So our slope is actually undefined. Okay, so again, on your calculator, it will say error, but the slope would be considered undefined. The equation of this particular line is x equals 2.